So this is the topic. Everybody can see this one. And I should start with one particular word, which comes every time whenever a technical session starts in case of poultry. The word starts with sustainability. So what exactly do we mean by sustainability? The broiler chicken, the laying hens. So I think the achievement in terms of performance has reached, I think its peak. It's really remarkable development in terms of genetics, in terms of nutrition, that nowadays we can have broiler chickens weighing more than 3 kilograms in 42 days with FCR of 1.4, 1.5. We cannot really, we could not really expect this one a decade ago. Now the challenge is how to sustain this performance. How to sustain this, how to keep this performance level on for the next years. For the coming years. Now, just an open question to the audience. There are so many stalwarts from academics, from industry, from everywhere. Just an open question. How many new molecules you have come across in the last couple of decades? Can you tell me? I can see many personalities here who are really fantastic in exploring new molecules across the globe. Now, just an open question. Can you answer this question? How many new molecules you have come across in the last couple of decades? We can find some genetically modified enzymes, some genetically modified probiotics, but is there any new molecule that we can use? I think there is none. Probably, if I'm not wrong, you will hardly find any new molecule which has come across the globe which can support poultry production. So without new molecule, how we can sustain this high performance? Very difficult. It's indeed difficult, if not impossible. So the time has come that let us explore something which is already present within the system. Within the system, there are many devices which can be explored, which can be utilized, and which can be translated into something which ultimately will give rise to better productivity in case of animals. Now, this is actually the topic of today. Now I'm asking another question, a funny question to you all. Say, for example, you have to catch a flight, say around 12:30 today, and you are still stuck in traffic jam. Okay? And I'm offering a very delicious dish to you. Sir, please take this one. Will you like it? Or will you really feel interested to take that dish? Anybody? Any answer?
Unless I'm sure I'll miss the flight.
Pardon?
Unless I'm sure I'll miss the flight.
Yes. If you are ready that, well, everything is gone, my flight is gone, so I'll be taking the food. Perfect. Otherwise, you won't. This is the fallacy, actually. This is the fallacy. The fallacy, why this is the fallacy? Fallacy means here your brain that is sending some signal to your gut that, boss, don't take anything. I'm not okay. I cannot relish the food. Okay. So, and at the same time, if I go a bit detailed, I may even find myself uncomfortable. It will be good that if I could use the washroom at that moment. Isn't it? I think so. That means there is something which is going on in the system, that the brain is sending some signals to my intestine, and the intestine is now sending some signals to its residents. There is some noise. Is it from me or from somewhere else? And what I'm trying to say here is that probably now there are 3 key players. Key players means the players. This is the host. Host means the animal itself, the environment, and the microbiota. Microbiota means this is the bacterial species which are present within the host. So these 3 key players are there which actually control everything. How the host interacts with the environment, how the host interacts with the microbiota, and in turn how the microbiota actually interacts with the host as well as the environment. This is the key thing in controlling the appetite, the controlling everything or controlling the behavior of the animal in terms of feeding and its growth and its responses. Now, this is actually described as the nutritional psychiatry. Nutritional psychiatry. This is a completely new topic which is being discussed a lot in case of human beings, human medicines, but it is not really that much discussed topic in case of animal nutrition. But this is a very interesting topic. Very interesting in the sense that, again, there are three key players I was talking about: the host, the microbiota, as well as the environment, and how they are interacting with each other. This is extremely important a point. And here, actually, you need to understand that, So this is a condition where I am happy. My brain is happy. The gut is healthy. So I am feeling hungry. And if I am feeling hungry, that means the bacteria which are present within the gut, they are also happy. They are also absolutely happy. They are in a position to digest whatever I'm eating. I mean, they are in a position to facilitate the digestion of the food, whatever I am eating. And in that way, this bacteria is maintaining a condition which is termed as eubiosis. On the contrary, if I consider a situation when I am unhappy means my brain is not happy. My brain is feeling tensed. My brain is not feeling well. It is not sensing everything is going good. In that case, what is happening? It is sending some signal to the intestine. It makes the intestine unhealthy, unhappy, unhealthy. And finally, if the intestine becomes unhealthy, it leads to a situation which is termed as dysbiosis. So there are two terminologies. One is eubiosis, another one is dysbiosis. And these are the situations which actually control the health and productivity of any animal species, including poultry. And it's true that it is also controlling the ultimate health condition of human beings. Now, as I was talking about the eubiosis and dysbiosis, what exactly they are? These are some very critical terminology, and I think everybody dealing with intestinal health, they come across this terminology, and they discuss about this terminology. Now, the situation is eubiosis means this is absolutely normal. Everything is going fine, going good. And in this condition, the pathogenic bacteria, the number of the pathogenic bacteria is really less. Really less means in what sense it is really less? You know that the bacteria, they are present in the small intestine, and these bacteria, they confront with the pathogens as a first line of defense. Because this is the small intestine, it is a small intestine which actually confronts any external source of infection through the feed, through the litter, through the drinking water, through the environment. So, whenever the bacteria which are present in the small intestine, they confront with the pathogenic organisms which are present in the environment, they start fighting with them. They try to outnumber these pathogenic bacteria. And this is the process by which a condition develops which is termed as eubiosis. Now, there are situations. Under those situations, somehow, the intestine gets compromised. The health of the intestine becomes compromised. And because of that compromisation, what happens? The number of the pathogens, they increase. And when the number of the pathogens increase, the good bacteria, the friendly bacteria, which are already present in the small intestine, they get outnumbered. And if those bacteria get outnumbered, then a situation arises when nothing goes well. And this situation is termed as dysbiosis. Now, how this is manifested? There are a lot of manifestations. But the most common manifestation which happens, which we can find, is histologically. You just have a look at the structure of the villi. A nicely constructed villi, they get this much eroded when a situation like dysbiosis arises. So this is eubiosis and dysbiosis. Now these definitions and this discussion is very important to understand what I'm going to discuss later on. So what I was talking about, that if I'm not healthy, if my brain is not healthy, my gut will also not be healthy. That means there must be something, communication, which is going on between the brain, the gut, as well as the bacteria which are present inside the gut. So this is called something, a dialogue which is going on between the host animal, between the gut of the host animal, as well as the bacteria which are present within the host animal. So what the host animal, in case of a poultry, what the host animal actually offers to the microbes? It offers a hospitable niche and the food which is not being digested by the animal itself. And in turn, what these bacteria do? These bacteria actually, they digest this undigested food. They provide some compounds which are termed as the neuroactive compounds. These compounds actually interferes or affects or influence, rather I should say the word influence the central nervous system, and finally they bring about some structural and functional changes in the small intestine. As a result of this, the host animal becomes healthy. So we generally consider that the relationship between the bacteria which are present in the intestine and the animal is a commensalism, a commensal organism. We term them as commensals, but actually this is not a commensalism, rather we can term this as mutualism, because not only the bacteria residing within the host, but at the same time the bacteria is giving something in lieu of whatever it is getting from the host. So this is not a mere commensalism, rather it's a mutualism, which actually the host animal as well as the bacteria present inside, they enjoy with each other. Now this dialogue which is going on between the brain as well as between the gut and the microbiome present within the gut, it's a two-directional, bidirectional. One is coming from the brain to the gut, and another one is the one which is going from the gut to the brain. So this is a bidirectional dialogue which goes on generally under different conditions. It depends upon that what condition is prevailing. Generally what happens, that as I say, that the bacteria which are present within the small intestine, they confront with any of the infectious agents through feed, the litter, through drinking water as well as from the environment. So it is the bacteria which are present within the gut which actually shows some changes. And during this change, the bacteria start sending some signals up to the brain so that the brain can become cautious. The brain can start sending some signals down to the small intestine, and finally the small intestine can become ready to combat with any situation which is actually signaling towards the impending threat of infection. So this is a bidirectional dialogue which goes on between the brain as well as the gut of the animal. Now, there must be some carrier which should carry the signals, just like that, the postman or the post person. So these are the neurotransmitter substances. These neurotransmitter substances, actually, they are the carrier molecules, and these carrier molecules, they carry the information from the brain down to the gut or from the gut up to the brain. These neurotransmitters may be of different types. Some are excitatory, that means it will stimulate the gut action or it will stimulate the brain action. They may be inhibitory, that means they will calm down the responses which the brain elicits, or it will calm down the responses which the gut will elicit. There may be some neuromodulators, that means they will keep on the function as it is but will modulate its degree of activities, and there are some hormones. Finally, when these neurotransmitter substances reach the site of action, they start releasing certain molecules, and these molecules actually execute the work. For example, these are the molecules. For example, one molecule is peptide YY, this PYY. This peptide YY is a molecule which is considered to be a hormone type of substance which is secreted from the mucosal cells. What is its function? When it is secreted, for example, we have taken, or an animal has taken up some food which is not digested. It needs some more time to be digested. There must be some signal which should come to the gut so that it can hold the digester for a longer period of time within the gut. So, the brain, under these situations, sends some signal to the gut. The gut now starts secreting this particular molecule, peptide YY, and this peptide YY works as a braking mechanism. The braking mechanism means it starts reverse peristalsis. So it will hold the digester for a longer period of time within the gut. The digester will be exposed to more amount of the digestive enzymes for a longer period of time, and so we can expect a greater digestibility. So this is how this entire dialogue process and its execution occurs within the system. Now how these neurotransmitters work actually. This is a very, very unique and very, very fascinating system. Now these neurotransmitters actually work by carrying out the signals from one neuron to the another one. That means there are nerve endings. So from one nerve ending, the neurotransmitter substance will take this forward to the next nerve ending. And this transmission is actually just nothing like a gate. This gate is operated by some ions like calcium, sodium, etc., etc. Now, if it is an excitatory neurotransmitter, for example, norepinephrine, we know about norepinephrine or epinephrine. These are excitatory. That means they will excite the neurotransmitter. When it comes from this neuron to the next one, it will excite the next neuron. So to do this, what it will do, this will simply open this gate. And once this gate is opened, the ions will enter through these gates. And as a result, there will be excitement. On the other hand, if it is inhibitory in nature, for example, this gamma-aminobutyric acid, what it will do? It will simply inhibit. It will keep the gate under locked condition. And if the gate remains locked, in that case, the ions will not be in a position to enter from the next one neuron to the next one. As a result, there will be an overall inhibition of activity. So this is the basic difference between an excitatory neurotransmitter and an inhibitory neurotransmitter. The neurotransmitter are generally secreted by the system. System means the intestine, the brain, and everything. But the interesting point is, these neurotransmitters are secreted by number of bacteria which are present within the system, within the gut. So what I was talking about initially, that since we do not have any new molecules developed in the last couple of decades, then why not to explore this mechanism by which the resident bacteria which are present within the system, they produce certain neurotransmitter substances, and these neurotransmitter substances are in a position to influence an animal's performance. Then why not to dig out this pathway to achieve some sustainability or some augmentation in production. Here you can see these bacterial species. All these bacterial species are present within the gut, within the system of the animals, and they are capable of producing one or more number of neurotransmitter substances which may be excitatory or which may be inhibitory, or they may be neuromodulators. Whatever it may be, my point of concern here is that if these bacteria are capable of producing these neurotransmitter substances, then why not to take an attempt to explore this pathway to augment the future productivity of animals. Let's concentrate on gamma-aminobutyric acid. This gamma-aminobutyric acid is something, an inhibitory neurotransmitter. That means it generally calms down the excitement. So if somebody is very much excited somehow, and if I can push some gamma-aminobutyric acid, GABA, so I can expect that, well, it will calm down, the response will calm down. Very interesting point is that it exerts a calming effect on the gastrointestinal tract. A calming effect, that means it sort of palliative action. Now how it works actually, let me go to the next slide, I can explain this one in a better way. That as I'm saying repeatedly, that the small intestine is the first point which confronts with any infection or any pathogen which is present in the environment, either through the feed, through drinking water, or through litter material, whatever it may be. So the bacteria, the pathogens, or any sort of irritant, that actually comes into the gut first of all. So they actually send some sort of pro-inflammatory stimuli onto the mucosal lining of the gut. So as soon as these pro-inflammatory stimuli come to the small intestinal mucosa, they start activating the macrophage system. The macrophage is the first line of defense that gets activated whenever there is any impending threat of infection. So as soon as these macrophages get activated, there will be secretion of the pro-inflammatory interleukins. So these pro-inflammatory interleukins, whenever these pro-inflammatory interleukins will start getting secreted, they will take away a huge quantity of the nutrients which the bird is consuming. This is a very paradoxical situation. Paradoxical situation means the system needs protection, but the protection comes at a cost. The cost of the nutrients. The nutrients, whatever nutrient the birds are consuming, that nutrients, instead of getting utilized for the growth and feed conversion, it is being utilized for production of the pro-inflammatory interleukins. So I'm not going to get anything which is expected actually. In this situation, this GABA, it plays a very important role. Since this gamma-aminobutyric acid is inhibitory in nature, it sends some inhibitory signal to the brain. In turn, the brain sends some signal through the vagus nerve, which is again an inhibitory nerve, that tells the small intestine not to be overreactive. Not to be overreactive. Yes, we need the protection. We need the protection against infection. We need that pro-inflammatory interleukins should be there. We need the macrophage system to be activated, but not to a great extent. There must not be any overt reaction, because overt reaction will consume a lot of nutrients from my system itself. So here lies the importance of GABA. So GABA, it sends signal to the brain that not to be overreactive, and at the same time it comes down the local stimulation which actually is responsible for synthesizing these pro-inflammatory interleukins. So this is a very, very fascinating description of what the role gamma-aminobutyric acid can play. This will actually explain that despite being inhibitory in nature, how this gamma-aminobutyric acid can stimulate growth. Again, I'll go deeper into the science. I'm sorry, but unless I go deep into the science, it will be very, very difficult to explain what actually GABA does. The point is that whenever GABA is synthesized, the GABA system is stimulated, what actually it does, it actually inhibits the acetylcholine esterase system. This acetylcholine esterase system is something which is, perhaps we know the system, the names of angiotensin 1 and angiotensin 2. So these are the system, the angiotensin 1 and angiotensin 2, which are secreted by the kidneys, and these kidneys are actually, this angiotensin system is actually inhibitory because it prevents the insulin-like growth factor. This insulin-like growth factor is something which stimulates the growth for poultry as well as other animals, and if this acetylcholine esterase system is activated, then this insulin-like growth factor system will be downregulated. As a result, the birds will experience depression in growth. If GABA system is stimulated by any means, in that case, this acetylcholine esterase system will be downregulated. And if the acetylcholine esterase system is downregulated, we can expect that this insulin-like growth factor mediated growth responses will be more. There will be stimulation in the ghrelin pathway. The ghrelin is one of the hormones which actually stimulates feed intake. And finally, there will be a better body weight and better feed conversion ratio. Because this is why this is important, because we know that whenever any impact is there on the brain of the bird or any other animal that actually disturbs the psychology of the bird, in that case, feed intake will be the first thing which is going to be impacted. So if we can maintain the feed intake at a normal level, in that case we can expect that, well, the bird's growth performance will be perfect. This is exactly what this GABA does. It downregulates the acetylcholine esterase system, upregulates the insulin-like growth factor as well as the ghrelin-mediated pathways, maintains the feed intake, and at the same time, it sustains the performance of the bird. This is some graphical representation of how this GABA works under conditions of stress, especially under heat stress. These black birds are related to the Cobb 500 birds, and this is actually representing the Ross birds. Now here actually, this is the normal condition. This is normal plus GABA supplementation. Extraneous, this is through drinking water. Then again, this is heat stress in absence of GABA and heat stressed animals in presence of gamma-aminobutyric acid. So under all the conditions, this is actually that
agouti protein related gene. This is another gene which is responsible for stimulation of the growth. And this is for the neuropeptide Y, another hormone which actually stimulates feed intake. So both the expression of both the genes are upregulated by gamma aminobutyric acid, either in presence of stress like heat stress or in absence of heat stress. So this actually shows that if somehow the GABA system can be stimulated within the body, it can be expected that at least feed intake will sustain. And if feed intake sustains, in that case we can expect a better body weight as well as feed conversion ratio, even in presence of number of stressor stimuli. There is another very interesting point which needs to be discussed here. This gamma aminobutyric acid, going to its inhibitory responses, it actually inhibits the movement of the circular muscles within the colon and the intestine. And at the same time, it actually inhibits the release of the acetylcholine. So both of these mechanisms, they do not allow the peristaltic movements to be uncontrolled. And if the peristaltic movement doesn't go uncontrolled, if it can be controlled, in that case, there are a number of situations. Under those situations, it is likely that the birds defecate a lot. We can experience the wet litter, we can experience the loose droppings. So all these problems can be solved if this GABA system can be upregulated by any means. Because this is actually stimulating this, is inhibiting the circulatory muscles in the colon and the large intestine, and it inhibits the acetylcholine secretion locally. Now, coming to direct effect of gamma aminobutyric acid in case of infection. So is it possible that this gamma aminobutyric acid can prevent enteric infection? It is a possibility, high possibility that it is possible, because under any situations it stimulates the secretion of the most of the interleukins which are going to, or the cytokines which are going to provide some sort of protective action against infection. The point is, this is something contradictory. This is something contradictory in what sense? Because in one of my earlier slides, I have just said that GABA keeps the inflammation under controlled situation. But here it is showing that it is stimulating the pro-inflammatory responses. This is somewhat a paradoxical statement, I agree. But the point is that it is always acceptable. We have to accept the fact that whatever inflammation is there, that inflammation, if it is a controlled one, then it is always desirable. But if it is uncontrolled, it is undesirable. That means if the pro-inflammatory responses go uncontrolled, overt expression of the pro-inflammatory responses, in that case we can expect a cost on the bird's performance. But if it is not uncontrolled, in that case we can expect that there will be protection, and this protection is possible to be achieved by GABA system activation. Now the question comes, if we supplement GABA from exogenous sources, will that be helpful? Probably yes, because this is data which actually shows the meta-analysis of at least 19 peer-reviewed articles, which actually detected that what may be the effect of GABA when it is supplemented from outside. And it shows that more than 80% of the cases which were conducted under heat stress condition, it shows positive responses. This means that if gamma aminobutyric acid is supplemented to the birds from external sources and under conditions of heat stress, it is likely, high possibility is there that more than 80% cases that there will be a positive response. This is quite encouraging. This is quite interesting a fact, in fact. Unfortunately, the data is not really conclusive because there is a dearth of data. We need to find out more data on this, because if you consider the other responses like antioxidant responses, growth response or laying performances, intestinal health, immune responses, endocrine hormone responses, or body temperature responses, you will find that these responses are quite variable. There may be, say, in Case of antioxidant responses, we get more than 60% of positive response. In case of growth responses, more than 70% we get positive responses. On the contrary, the immune response, it is just a 50-50 response in enhancement, like that. But the possibility is that if we consider the general trend shows that supplementation of GABA from exogenous sources is likely to influence positively most of the performance-related parameters in case of poultry. There is another critical question. What should be the dose response and what should be the duration effect? That means if I keep on increasing the dose of the supplemental gamma-aminobutyric acid, because it is ultimately an inhibitory substance. So if it goes uncontrolled, in that case, what will happen? There is a possibility that there will be uncontrolled inhibition of responses, or if we continue the supplementation for a longer period of time, then also the same thing can happen. Again, I must say that the data is not really sufficient, but in general, what we can say that more or less, if the dose of the compound is increased when supplemented from exogenous sources, there will be more or less positive effect on body weight gain and feed conversion ratio in case of broilers as well as layers, and there will be general improvement in case of that immune parameters. But must say that if it is the activation of the endogenous GABA system, or if it is the effect of the supplementation, exogenous supplementation of GABA, it is really very difficult to say right at this moment since data is still lacking. Only I'm talking about the general trends. This is the dose response. I mean the doses which can be applied when it is supplemented from exogenous sources. Finally, if we want to sum up, we can say that be it exogenous or endogenous, they complement each other's action. So if it is exogenous sources from the exogenous sources, or if it is from the endogenous sources, the gamma-aminobutyric acid will finally complement each other, and this will ultimately lead to the improvement in the local and the systemic immunity. It will improve the feed intake as well as performance under condition of stress. It will sequester the effects on the pro-inflammatory responses on the small intestine. It will upregulate the orexigenic genes by which feed intake will be sustained, and this will finally improve the performance of the bird. Or rather, we can say that this approach of stimulating the endogenous GABA activity as well as complementing the endogenous activity through exogenous sources, it is probably a way by which the sustainability that we are talking about can be achieved in future. Thank you. Probably the high possibility is that if you talk about this dysbacteriosis as well as necrotic enteritis issues, because the point is that directly gamma-aminobutyric acid will not reduce the incidences of necrotic enteritis or enteritis. But what it actually do is it will reduce the inflammatory responses. So if you find that with say 1 dose of infection, there is X dose of pro-inflammatory response. With the same dose of infection, you will find that less pro-inflammatory response. And if the inflammatory response is reduced, in that case, you can expect that a good amount of the nutrients will be preserved for the growth.
Correct.
So there will not be a direct effect of gamma-aminobutyric acid on enteritis or the necrotic enteritis. But what exactly it will do, it will just keep the infection under control. So by means it will be an added strategy. Whenever you are not in a position to control the infection, even if you are in a position to control the infection, but you cannot control the immune reactions, so that can be controlled, and in this way you can conserve the nutrients for the bird's growth.
Yeah. Thank you so much.
Okay.
Thank you, Dr. Haldar.